Here's the script, 812 words, within the 5% target range. In 1899, in a physiology lab in London, a length of dog intestine was cut completely free from the spinal cord, the brain, every nerve that was supposed to control it, and it kept digesting anyway in perfect rhythm on its own schedule. Two researchers watched tissue with no possible way to think, keep making decisions. And over a century later, scientists still cannot fully explain how a system with no brain is running one. The researchers were William Bayliss and Ernest Starling, two physiologists working out of University College London. At the time, digestion was assumed to be simple. Food enters, a nerve signal fires, muscles contract, the food moves along. A basic reflex dictated top-down from the brain. Bayliss and Starling weren't trying to overturn that idea. They were testing intestinal pressure in an anesthetized dog, expecting a predictable, reflexive result. What they got instead didn't fit anything in the medical textbooks of 1899. The tissue behaved like it was making its own calls. Here's the first anomaly. When they stretched a section of the intestine, it didn't just contract at that point. A wave moved down the tube one direction only, pushing forward like it was following an internal map. They cut the nerve supply from the spinal cord. The wave kept moving. They tried severing the connection higher up. It still moved. Whatever was directing that motion wasn't coming from the central nervous system at all. It was coming from inside the gut wall itself. Nobody in that lab expected disconnected tissue to still know exactly what to do next. The obvious theory was a local reflex arc, a simple, primitive loop of nerve cells confined to the intestinal wall, just complex enough to trigger one basic motion and nothing more. Scientists comforted themselves with this. A dumb reflex, they said, not real processing. It explained away the strangeness. Peristalsis could carry on being viewed as mechanical, automatic, beneath real thought. For a while, that answer held. Then the complication arrived, and it broke that theory completely. As researchers kept probing, they found the intestinal wall wasn't running one simple loop. It was running an entire nervous system, one built from over 500 million neurons, roughly the same number found in the spinal cord of a cat. It used its own neurotransmitters. It coordinated timing, sequencing, and pressure without a single signal traveling up to the brain first. A basic reflex arc doesn't need that scale of hardware. You don't build 500 million neurons to move food 12 feet down a tube. Something more was clearly happening, and nobody could say what it was actually for. That's the core of the mystery scientists now call the enteric nervous system, sometimes referred to, half-jokingly, as the second brain. It doesn't just move food. It monitors, adjusts, and reacts to signals faster than conscious thought can register them. And here's the detail that still unsettles researchers. Of all the communication happening along the vagus nerve, the primary line between gut and brain, roughly 90% of it travels upward, from gut to brain, not downward. Your stomach is not a passive organ waiting for instructions. It is sending more information to your brain than it receives. The unease you feel walking into a room, the hesitation before a decision that later proves correct, maybe signals your gut registered and forwarded before your conscious brain had assembled the thought at all. You'd expect the brain to be first. The evidence keeps suggesting it isn't. Competing explanations have tried to close this case for over a century, and each one fails at the same point. The simple reflex theory can't account for 500 million independent neurons. The hormonal signal theory can't explain the speed or the directionality, why the gut consistently reports before it's told anything. Even modern neuroscience, with functional imaging and gut-brain axis research funded across dozens of universities, has only been able to map that the signals exist and travel upstream first. Nobody has produced a full model of what the enteric nervous system is independently deciding, or how much of what we call intuition originates there before the brain ever gets involved. Researchers can observe the traffic. They cannot yet read what it's saying. So the tissue that started this, over 120 years ago on a table in a London laboratory, still hasn't given up its answer. A system built from more neurons than most spinal cords, sending most of its signals upward, unsupervised by the organ we call the seat of thought. If the body chooses before the brain finishes deciding, what exactly is doing the choosing? And how much of what we call a gut feeling was never really a feeling at all, but a verdict already reached, before your mind was even told there was a decision to make. Note, I anchored this to a real, verifiable 1899 case, Bayliss and Starling's discovery of the enteric nervous system. Rather than inventing a fictional anomaly, matching how the channel already treats brain topics, temporal lobe, thalamus-Wernicke's area, as fact-based mysteries rather than true crime.